Hello and welcome to lesson 1 of our A-level course. Today we're going to solve linear equations, but before I do that I'd like to just start with how I see the A-level course panning out. As you can see here on the overview, we've got year 12, we're going to be focusing on C1, C2 and S1. Today we're going to start here with C1, but then next year we'll be focusing on C3, C4, and we'll have a choice of either Mechanics 1 or Decision 1. At the moment we are definitely going to be doing S1 as the first course additional module. But less of that, let's get stuck into the lesson proper. Now, as we start lesson 1 proper, you'll be able to see here that I'm using Notebook. I do hope to make this available online to you all, but I'm going to click on solving equations and we're going to go through some of the equations that I think you should be able to solve. So without further ado, let's get started with example 1. And as you can see here, we've got 5x minus 3 equals 2x plus 15. Now, the way I've previously done it is I like to add 3 to both sides, so that we're left with 5x equals 2x plus 18, and then I take 2x from both sides, which then leaves me with all my x's on this side and all my numbers on this side. 3 times what makes 18? Well, another way is doing 18 divided by 3, which is 6. So that's the first example done for us. Now let's move on to example 2. So here on example 2 we've got lots and lots of information on the line. 3x minus 5 plus 7x plus 3 equals 5x minus 11 plus 3x minus 7. So the first thing I'm going to do is try and simplify each side of the equation. So we've got 3x here and we've got 7x, so that's 10x. I've got minus 5 and plus 3, which makes minus 2, and that's going to be equal to 5x plus 3x is 8x, and minus 10 minus 7, minus 11 minus 7 is minus 18. Okay, now this is very similar to what we had before. Just look up here, we've now got equations with 2 x's, 1 on this side, 1 on that side, just like we have here, 1 on this side and 1 on that side. So without further ado, let's get going. So add 2 to both sides, and you'll find that 10x is equal to 8x plus, minus 16. The reason why I added 2 was because I wanted to get rid of that negative 2 there. Now I need to get rid of this 8x, so I'm going to get rid of the 8x by taking 8x from both sides, and that leaves me with 2x equals minus 16. Well, if you ignore the minus, 2 watts makes 16, well, that's 2 8s are 16, don't forget to put your minus in at the end. Okay, and now let's move on to example 3. Here we go. So, let me just give myself a little bit more space here. Move this right the way down, out of the way, and that's working blue. So straight away here you can see there's lots of brackets, so we're going to have to expand the brackets. So let's do that first. 5 times x is 5x, 5 times 3 is 15. At this stage I'm not drawing boxes or drawing loops in, you should be able to do this yourself, and that's why 4 times 2x is 8x, that's why we're in the A-level course. 4 times 3, but it's not 3, it's a negative 3, so 4 times 3 is 12, don't forget the negative, makes minus 12. And here we've got 2 times 2x is 4x, and 2 times 15 is 30, and it's plus 30. This, as you can see, is a little bit more difficult because now we've got to try to bring everything together, so because this side's got lots of unknowns, so 5x plus 8x is 13x, 15 minus 12 is plus 3, and that's equal to 4x plus 30. So take 3 from both sides, and we're left with 13x equals 4x plus 27. Take away 4x from both sides, and we're left with 9x equals 27. And that means that going through your 9 times table, 9 3s are 27, so we've solved this question here. At this stage now, I'd recommend that you pause the video, check that you can do all those 3 examples. If you can, let's move on to example 4 and 5, which, as you can see here, are going to be a little bit more tough. So, they only are a little bit more tough because they look a little bit different, but the same principle applies. So, if you've paused the video, fantastic. What I'm going to do now is I'm just going to insert some more space, and let's do example 4. For this one, I want to have you thinking a little bit. This is a little thought that I have when I do things like this. These look like fractions. Now if I had 1/4 minus 1/3, okay, probably not the nicest of ideas, but the first thing that you'd probably want to do is get the same denominator on the bottom. Well, that's really easy to do. You can do that, no problem at all. And the principle's exactly the same here when we go on to these algebraic fractions. We need to get the same denominator on the bottom. So what I'm going to do is I'm going to say, well, let's get it so that it's over 12. What if I times this side by? Well, I've times this side by 3. So I'm going to get 3x minus 5 in brackets. And what if I times this 3 by to get 12? Well, I times it by 4. So on the top, that's going to be 4 minus x. Now, at this stage, I haven't done anything with the 5. Okay, so let's just keep that the same at the moment. Now, what I would like to do here is I'd like to say, well, 3x minus 15 minus 16. Now, I'm going to put this as plus 4x. And the reason why I'm going to do that is because I'm treating this minus here as though it's attached to this 4 here. So it becomes minus and a minus make a plus. And because we've got the same number on the bottom, we can just write this whole thing over 12. Now, okay, what have I forgotten to do? Well, at the moment, what I've forgotten to do is make it equal to 5. Now that I've got the 12 on the bottom, I can just take that across over to the other side, and you get 3x minus 15 minus 16 plus 4x equals 5 times 12, which is 60. And what does this become then? Well, you've got 3x, you've got 4x, that's 7x. Minus 15 minus 16 is minus 31, equals 60. Take 31 over to the other side, or add 31 to both sides, and you get 91 is equal to 7x. And how many? 91 go into 7, does 7 go into 91? Yes, it does. It goes in 13 times. So, although it looked horrible, the hard bit was getting this bit here, the denominator, the same. So I'm hoping that you can see that bringing these two together was the hardest part, getting the denominator the same. Now, we can do that with using the grid method or anything like that, but at this stage I'd like you just to pause the video, check that you're okay with what I've done there, because there were a few little tricks that I'd used, such as also when I used this bit here and I pretended that the negative was with the 4. So, little tricks. Remember, pause the video and go over this at any time. Now I'm going to move on to the last question now, before you have some catch-up questions to do yourself. And again, I'm going to give myself some space here. You can see this is a little bit more tricky because in this case the denominators are on the bottom. But also this looks a little bit different because, well, one fraction is equal to another. So what I'm going to do is I'm going to do a little trick here. I'm going to write out the question again. As you can see there. Now the trick I'm going to do is I'm going to say, well, if this is on the bottom here and I take it to the other side, it becomes on the top. So I get 8 times x plus 1. And this bit here was on the bottom, so if I take it to the other side, it goes on the top, so we get 7x minus 2. Now actually, this looks quite easy to solve, so let's go through and do it. 7x minus 14 equals 8x plus 8. Okay, what I'm going to do is I'm going to add 14 to both sides. So you get 7x equals 8x plus 22. And now I'm going to take 8x from both sides. So I get minus x equals 22. So that means x equals minus 22. Okay, so if you've got that, please feel free to pause the video or move on to these questions here. Now, obviously, I'd like you to try these questions. They start off quite simple, but they do get to some challenging questions towards the end. Feel free to pause, rewind, and go over any questions that you might need. Okay.